Welcome to Digital Electronics and Computer Organization course. I am Sudhakar Ajmera, Assistant Professor, Department of VC, MLR Institute of Technology, Hyderabad. Today we will see Karnaugh map method, which is most important in digital electronics circuits designing. We will see K-map method, why this K-map method is used and what it is. So K-map is a graphical method or a representation of cells for simplifying Boolean expressions while designing digital circuits. So K-map is nothing but Karnaugh map, which is very much helpful in minimization of logic functions while grouping adjacent ones or zeros in SOP or POS form. So here K-map is very much useful without using Boolean algebra theorems, properties and postulates. So purpose of K-map is to reduce the number of logic gates in a circuit while maintaining the same function. If we reduce the number of logic gates, there will be a lot of uses in terms of cost and complexity will be reduced, and there are so many applications are there if we minimize the logic functions while designing the circuits. So all these applications of K-map I will do in another session, we will see as a part 2 along with some minimization problems. So here important in K-map is while representing K-map, here adjacent cells differ by only one variable. While representing cells of K-map, so adjacent cells must be differed by only one variable. What is what we will see while representing K-map. And one more important is while grouping cells, we can group 1 cell, 2 cell, 4 cell and 8 cell. So what I mean to say, powers of 2 we can group it. And in each cell in the K-map corresponds to a min term, that is generally will use it for SOP form, and for max term that is generally will use for PS form. So these are very important point. Keep it in mind while drawing any K-map method. So as a part of this, very important is there are 2 variable K-map, 4 variable K-map, 5 variable K-maps are possible. 1 variable K-map is not possible. So here as a part of this we will see 2 variable K-map representation, how we can represent 2 variable K-map. So here if you observe, this is what 2 variable K-map. Let us take variables are x comma y, assume. How I can represent 2 variable K-map in terms of cells? So using this 2 variable, there are how many possibilities? 4 combinations are possible. So let us take 4 possibilities are 0 0, 0 1, 1 0, 1 1. And how we can represent all this in terms of cells? You can observe here. It's a graphical method. K-map is a graphical method, and we will represent this 2 variable with 4 possibilities. So I'll take here x variable here, y variable here, and here y denotes columns and x denotes rows. X denotes rows. Using this x single variable, there are 0 and 1 logics are possible. Using y, 0, 1 logic are possible. If you want to represent this, how we can represent? Generally, we will take rows and columns in 2-dimensional. So if you want to represent these cells, these all are cells, right? So here using these 2 variables, x and y, 4 cells are possible. and we will represent these 4 possibilities 0, 0, 0, 1, 1, 0, 1, 1 in these cells. So here first I want to represent this, okay, rows versus column I have to represent. So for this cell, what are the values here? Row means x value is 0, y value is 0. So generally I will represent row and column in terms of row and column. For this cell, x and y value are 0, 0. Likewise, I will represent for each and every cell x and y values. For this entire row, x value is 0, y value is 1. For this entire row, x value is 1 and y value is 0. For this entire row, x value is 1 and for this one, y value is 1. So like this, I will represent, okay, 2 variable K map for these combinations in these cells. So this is what representation of 2 variable K map. Likewise, I can also represent 3 variable K map. Let us assume variables as x, y, z. Using this x, y, z, let us see what are the possibilities. So using 3 variable K map, there are 8 possibilities. Using these 3 variables, there are 8 possibilities. Those 8 possibilities are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So these are what? 8 possibilities. That is from 0 to 7, I can say. So 0 yatham, first, second, third, fourth, 5, 6, 7. I'll start from 0. So these 8 possibilities, I'll get it using these 3 variables. So how to represent these values in 3 variable K map is, I can represent like this. Either I can represent like this. So using this 3 variable, 8 cells are possible. So for this, what I'll take, x I'll take to represent rows and yz to represent column. So x is used for representing rows and yz is used for representing column. So here using this x variable, only 2 possibilities, that is either 0 or 1. Using these 2 variables yz, there are 4 possibilities. Okay, 0, 0, 0, 1, 1, 1, 1, 0. Okay, so here if you want to represent this, cell, okay, how we can represent? Always will write x, y, z values for each and every cells, x, y, z values, like this. So what is x value, y value, z value for each and every combinations? For this cell, what is the x value here? As I said, x will represent complete rows. So here 2 rows are possible. Okay, row 0 and row 1. If you want to represent this first cell, what is the x value for this one? 0. This x indicates what? Row. So row value for this one, first row is 0 and yz value for this cell is, okay, 0, 0. Okay, likewise I will represent for entire this first row, x value will become 0 and yz value become its column value. So for this cell, okay, yz value is 0, 1. For this cell, okay, yz value is 1, 1. For this cell, yz value is 1, 0. Likewise, if I want to represent this second row values, so x value for this one is 1. For entire this row, second row, x value is 1 and yz value is corresponding column values. So for this, okay, yz value is 0, 0, 0, 1, 1, 1, 1, 0. So like this I can represent, okay, 3 variable K map. And what is the value for this one? 0 0 0 means I can represent M0, and this is M1, this is M3, this is what, M2, and this is what, M4, M5, M7, M6. So I want to rewrite again fairly. So X, Y, Z, 0 0 0 1 1 1 1 0 0 1. So here if I want to write the value of this one, means X, Y, Z values. What is the X, Y, Z value? 0 0 0. Okay, for this one X, Y, Z value 0 0 1. For this one X, Y, Z value 0 1 1. For this one X, Y, Z value 0 1 0. For this one X, Y, Z value what it is, 1 0 0. X, Y, Z value 1 0 1. X, Y, Z value 1 1 1. X, Y, Z value 1 1 0. And what it is, 0 0 0 means I can write M0. So here M1. So 0 1 1 means 3. So M3. This is what? M2. This is what? M4. This is what? M5. 1 0 1 means 5. That is M5. And this is what? 1 1 1 means 7. So M7. And finally 1 1 0 is M6. So these are the terms I have represented. Let us say M0, M1, M2, M3, M4, M5, M6, M7. So like this I can represent 3 variable K map. While represent this cell values, if you observe using this 2 variable YZ, okay, how many possibilities? Using 2 variables, 4 possibilities. What are those 4 possibilities generally? So 0 0, 0 1, 1 1, 1 0. While representing this 0 0 0 1 1 1 1 0, I have to represent like this. So first one you take 0 0, then 0 1, then generally I should take what it is. Sorry, this is 0 0 0 1 1 0 1 1. So generally I should take what it is, 1 0, but instead of taking this 1 0 I took 1 1, because in previous slide I have discussed what it is, adjacent cells differ by only one variable while representing cells. So here what does it mean? In previous 2 variable K map, here these 2 cells are adjacent to each other. So here if you observe its value, this cell value, Y value is 0, and here Y value is 1, and here 0 and 1 column value. So in the same way here also inside values 0 0 0 1. So 0 0 0 1. They must differ by only one variable. So you can observe like this. Okay, and here also you can represent, here also you can observe, they will differ by only one value. So 0 and 1. The same way here also you can observe, while representing these 2 cells M0 and M1, if you observe their column values 0 0 and 0 1, 0 0 0 1, 0 0 0 1, in how many bits they will differ? Only 1 bit. So they have eligibility to write besides. So 0 0 0 1. And if you observe M1 term and M3 term, M1 and M3, so that is 0 1 and 1 1. These 2 terms if you observe 0 1 and 1 1, they are differed by only 1 bit. So they can kept besides. And next one 1 1 with 1 0. If you observe 1 1 with 1 0, 1 1 with 1 0, they are differed by only 1 bit. Okay. Instead, if you keep 0 1 and 1 0 besides, what will happen here? 2 bits change will be there, 0 1 and 1 0. So this should not happen. That is why I am keeping here 0 0 0 1 1 1 1 0, because adjacent cells must differ by only 1 bit. So this is how I can represent 3 variable K map. One more thing, in another way also I can represent. You can observe, or else I can represent like this also. So here what I'll take, x, y and z variable. So here 0 0 0 1 1 0, I should not take 1 0 because adjacent cells must be differ by only 1 bit. So that is why I should take 1 1 and 1 0 and 0 1. So if I want to write xyz values for each and every cell, so what is the xyz value for this rows and column? Xy value for this first row is, okay, 0 0 0 0, and what is the z value for this one? You see corresponding column value, this is 0, and corresponding column value for this one is 1. Like that I should fill all xyz values. So for this one 0 1 0, next to 0 1 1, next to 1 1 0, next to 1 1 1. Next for this one I should take 1 0, and what is the column value here? 0. Next xy value is 1 0, and what is the column value here? 1. So like this I should fill. And what is the 0 0 0 here? M0, and 0 0 1 is M1, 0 1 0 is 2, that is M2, 0 1 1 is 3, that is M3, 1 1 0 is 6, so M6. Next this is M7, 1 0 0 is what? M4, 1 0 1 is M5. So finally I can represent K map in this way or in this way also for 3 variable K map. Let us move on to 4 variable K map. So here for 4 variable K map I have to assume variables as, what it is? I have to assume variables as, let us take W, X, Y, Z. Okay, 4 variables we have to assume, that is A, B, C, D or W, X, Y, Z. Using these 4 variables, how many cells are possible? Total 16 cells or combinations are possible. So what are those 16 cells or combinations? Let us take W, X, Y, Z. That is from 0 to 15, means total 16 combinations are possible. So I should write using these 4 variables from 0 to 15. I have to write from 0 to 15. So M0, M1, M2 and so on M15. So what is M1 term? 0 0 0 1. M2 means 0 0 1 0. So M3 means 0 0 1 1. Like this I have to fill. 15 means all ones. So all these 16 combinations I should keep in 4 variable K map. Like this. So here I'll take here 4 variables. I'll take 2 variables for indicating what it is, row, and next to remaining YZ, 2 variables is for indicating columns. Okay. So here using 2 variables, how many possibilities I can get it? 4 possibilities. What are those? That is 0 0 0 1 1 1 1 0. Here 0 0 0 1 1 1 1 0. If you want to represent this W, X, Y, Z value for this one, okay, what is W, X, Y, Z value? So Wx will represent row value. For this first row, what is the Wx value? 0, 0. And what is first column YZ value? 0, 0. 0, 0. So like this, I can fill all this gap. For entire this first row, what is Wx value? Is 0, 0, 0, 0, 0, 0. Right? And what is YZ value for this next column? 0, 1, 1, 1, 1, 0. You can observe all these values. These are what? Column values, and these are what? Rows values. So like this, I can fill 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 1, 0, 1, 1, 0. Next, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 1, 1, 1, 1, 0. Next, 1, 0, 0, 0, 1, 0, 0, 1. Next, 1, 0, 1, 1. Next, 1, 0, 1, 0. So if I want to write all this, so how I can represent this Wx, Yz, final value, what I mean to say here is 0, 0, 0 means what I can write? M0. So next 0, 0, 0, 1 means M1. So this is what? M3. Then M2. Like this, this is what? M4, M5, next M7, next M6. Next, what it is? M8, 1, 0, 0 means 1, 8, 1, 0, 0, 0 means M8. Next 1, 0, 0, 1 means M9. Then 1, 0, 1, 0 means M10. Next M11. What it is? 1, 1, 0, 0. 1, 1, 0, 0 means M12, M13, M14 and M15. So like this, I can represent, okay, 4 variable K map. Next, 5 variable K map. So assume variables as A, B, C, D, E. So these are my 5 variables. Using these 5 variables, how many possibilities I'll have? 32 possibilities I'll have. So what are those 32 possibilities? I can write from 0 to 31 means 32 possibilities. So what are those? First one, 0th possibility, first, second, and so on up to 15, then 16, then 17, and so on up to 31 possibilities I can write. So 0, how can I represent using this 5 variable? 0, 0, 0, 0, 0. Next 1 means 0, 0, 0, 0, 1. Next 2 means 0, 0, 0, 1, 0. Binary equivalence I can write. Next 15 means 0, 1, 1, 1, 1. And 16 means 1, 0, 0, 0, 0. 17 means 1, 0, 0, 0, 1. Like that, 31 means 1, 1, 1, 1, 1. So, like this, I will represent all these 16 combinations. Okay. And one thing you observe here, for first 16 combinations, that is from 0 to 15, what is the A value here? Completely 0. And for remaining 16 combinations, that is 16 to 31 terms, what is the A value here? Completely 1. And remaining rest of B, C, D, E values are same for first 16 and next 16. So here I need to draw 4 variable K map. stating A is called 0 combinations and A is called 1 combinations. So how I can represent this 5 variable K map using 4 variable? I have to take 2 4 variable K map like this. Okay, and they will differ in terms of A value only. For first 16 combinations, that is 0 to 15, A value is 0, and next to 16 combinations, okay, A value is 1. So how I can represent? So A is equal 0 and A is equal 1 for this. Next, remaining values are same, that is B, C, D, E, and here also B, C, D, E. Okay, so this is what 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Here also 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. So here M0, M1, M2, M3, M4, M5, M6, M7, next to M8, M9, M10, M11, next to M12, M13, M14, M15 terms will come. So first 16 combinations will come in A is equal 0 graph, and next 16 combinations, that is from M16 to M31 will come here. So M16, M17, M18, M19, M20, M21, M22, M23, M24, M25, M26, M27, M28, M29, M30, M31 combinations will come. So like this I can represent 5 variable K map. So today what we have discussed is, we have discussed about K map method, and we have seen how to represent 2 variable, 3 variable, 4 variable and 5 variable K map. For next session we will see applications of K maps, min terms, max terms and canonical and standard forms as next part. Thank you.